you and Caleb and Kyle. Give me one of your nomenclature examples.
Okay.
And the rest of us are going to answer it, okay? Go ahead.
Are we allowed to do acids?
Sure. It's in the bucket of nomenclature.
Okay. I did. I did lithium acetate.
Okay, so I'm spelling that out right, and they're going to tell us the formula?
Yeah.
Okay, so guys, lithium, don't look at your polyatomics. Lithium acetate. Take 30 seconds. Give me a second. EJ, start off.
Li-H2.
Not H first. It goes in alphabetical order.
C2.
C2,
H3.
H3, O2. What's the charge of lithium? Look at your periodic table. It's in group 1. 1 plus, what's the charge of acetate? 1 minus, so 1 plus, 1 minus, crisscross, they both are 1s. We don't write anything down. Awesome. Good. This group right here, Praneet's group. You guys give me one for the group.
Write the following formula and use it as sodium trisulfate.
Ooh, not a thing.
Not a thing.
Sodium. Okay, so that's a really good point. If you say sodium, that's a metal, right?
Yeah.
Are you allowed to put prefixes with a metal? Because a metal means it's an ionic compound, right? A metal and a non-metal. So if you're an ionic compound, do you ever use prefixes like that? So give me something else from someone else in your group. Robbie or Miles or Cameron.
Nitric acid.
Okay, nitric acid. So he's going with the acids. All right, guys, take 10 seconds. Trying not to look at your polyatomic ions. Caleb, what you got, man? You know this formula?
Is it like H?
Well, I'm gonna say H. Why are you putting 2 there? Where are you getting that information from? Okay, well, let's skip the 2 for a minute. What's next? Okay, so nitric is coming from nitrate, right? That's the it got ate too much thing. So it's nitrate. What is nitrate? And then that charge is a 1 minus. So nitrate has a 1 minus charge. H plus has a 1 plus charge. So 1 and 1, nothing needs to be crisscrossed. You want to sit on that side so you can see me? Yeah. Okay. McKinley's group. You guys give me an example, and then we'll write the formula. We'll write the name, whichever way you guys go about it. Go for it, DJ.
Ammonium chloride.
And I'm writing this out, right, as a name. Ammonium chlorate, perchlorate. The hardest one. Okay, so think about it. Think about it. Everyone feels like they're okay. They know. You know or you don't? Okay. Who knows ammonium? So Kyle knows ammonium. Anybody else? Ammonium. It's that weird one that doesn't even look like it sounds. So go for it.
It's NO4. H.
NH4, he's what he meant, right? Caleb's like, oh no, I did it. Okay. So NH4, and that's actually a 1 plus charge. So let's just talk about ammonium first, and then separately, who knows perchlorate, not EJ? Perchlorate. Maybe you guys can tell me chlorate. Take a stab at it.
Chlorine, ClO3.
So just simply chlorate is ClO3.
Yeah.
So if I'm perchlorate, I plus 1 oxygen. So I'm ClO4, and that happens to also have a -1 charge. Ammonium has a +1 charge, so then put those together. EJ, what is it? ClO4. Right, because these 4s here and here will not be touched because they are actually part of the polyatomic ion. Don't be a homewrecker. Don't break it up. It needs to stay with this family. And those charges, the ones and ones are the ones that are crisscrossed. Okay, overall, pretty good. Those are some hard ones. All right, so I'm going to go ahead and start. Yeah.
Why do you add the O again, like after?
Because those little, so when I just have a polyatomic ion, let's just say chlorate, and I know chlorate, I know it's ClO3. Anytime I adjust the name just a teeny bit, it actually makes the oxygens change. And so what if I have instead of chlorate, I have chlorite. So chlorate is ClO3, 1 minus. that ending changing to chlorite is then meaning what? Anybody? ClO2, right? You move the oxygen down one. And additionally, if I add something in the front like this, that per means to plus one oxygen. So that's why I went from ClO3 to ClO4. It's just the system of how those small changes make a difference. And so knowing that system helps you. I can add per to anything, and you're going to know, oh, it goes up one. I can do ite to anything, and that means you know you're going to drop in oxygen. So it's just the system. Okay, so let's look at the stuff from last time, because I want to walk through the first couple of examples, and then we're going to see where you actually need me. And I want your feedback on this before I start just showing everything. So when you read a question like this, the first thing you need to do is make sure you know your nomenclature. Nomenclature is going to be hitting us pretty hard here in the next couple weeks, so make sure you're practicing that. So chromium 3 oxide, C2O3. Give me a thumbs up if you got the formula. And this is where I get disappointed, because if you're like, I didn't know how to get started, baby steps is at least going through and getting all the formulas. Second baby step is at least setting up what's my given, like the thing given to me, the unit given to me, and what's my question. Doesn't take much knowledge, doesn't take much application, it's just reading the question. Next baby step is actually setting up that very, very first step of the problem. If that's as far as you get, I just can see you try. If you literally have nothing in your paper, I can't help, because I don't even know where your confusion is. So at this point, we know we have moles, and we're looking for grams. Then your thoughts in your head is there a direct conversion between moles and grams? Yes, you remember that 3-pronged thing we had yesterday? It's that middle step from moles to mass. So as you set up generic skeleton like this, your 10 moles of chromium 3 oxide, you know that moles and moles have to cancel. The only way they're going to cancel is if they're on top and bottom of a fraction. And then you also know there is a relationship between moles and grams, which is molar mass. And so the one was always that, a mole, you always have 1 mole and it related to these 3 things. So the one number goes with the mole, 1 number goes with the grams. 151.9. Everybody agree? Okay, and where did you get that?
You have to find the molar mass of Cr2O3
By adding it up from
the chromium 3 oxide.
Okay, so from the periodic table, though, you pull the mass of the periodic table. Okay. So, what is it, my notes? Here it is. So, what did you guys get once you multiply 10 times 151.9? Anybody?
1,519.
Wait, what?
0.89.
Okay, so this is how many grams you got initially. How many sig figs should be there?
3.
3 sig figs, so round that to 3 sig figs.
1,520.
Right, so 1520 grams of chromium 3 oxide. I have to hesitate writing the 3 there, because you say chromium 3, you're like, if you put the Cr3, the 3 actually gets crisscrossed. Okay, not a bad one, single step problem. Next one, we have our generic setup, and I think this is helpful to start with just your question that you're given in your question, because then it helps you understand can I do this in 1 step, or is this going to be multiple steps? So in this one, you're given moles, and you're asked for grams. What do we see here? Direct conversion or multiple steps? Direct conversion, and that's again the moles mass. That's that middle one we dealt with yesterday. And this one is really simple because it's just a single element. Pull the information off the periodic table. The only thing you really have to make sure is that you put the mole on top here, and you have to cancel the mole by putting in the bottom over here. And 1 mole of potassium weighs 39.1. And what is that, Caleb or Kyle? 2 correct sig figs.
2 correct sig figs, 130 grams.
So 130 like this.
You gotta put it.
Nice. That decimal actually means it's holding the 0 as a sig fig. So there should be 3 sig figs, and that's 130 grams of potassium.
Yeah.
Okay, so those were 2. I got you started with simple ones because that's really just practicing nomenclature and a molar mass or a molar mass conversion. Okay, next one. We have molecules of CCl4. Who got the formula? Carbon tetrachloride. Thumbs up? Give me a thumbs up. Okay, that's one of those covalent ones. When you see tetra, you're like, oh, covalent. Let's go ahead and put the 4 with the chlorine. So we're given molecules and we're asking for grams. Direct conversion or multi-step problem? Multi-step, because there's nothing here that has that connection like we had on our mole map yesterday. So molecules is up here with the particles, grams was here with the molar mass, and liters were down here with the molar volume. So if I'm starting with molecules, all you're going to do is, this is why you have this map, is this because like most people can actually visualize this in their head. If you have your molecules, what's the only thing it's connected to? You have to go to moles first, right? And this is a two-way street. You can go both ways, but we're going to go from molecules to moles first. That's moles of CCl4. And then the question is to get to grams of CCl4, so then what would be my next step? From moles to grams. You see it connects, it's literally what's connected. You can't go straight from here to grams because there's no connection there. That's why you have to go to the mole first. It's like a bus stop. You stop there and then you go someplace else. Okay? So utilizing that logic, we have set up our given of 4.6 times 10 to the negative 25th molecules. From molecules to moles, that first step, that connection was Avogadro's number, 6.022 times 10 to the 23rd, or 6.02 times 10 to the 23rd. And so the molecules here will cancel. Molecules, and we're in moles of CCl4. And then your final step would have to be from moles to mass. What was the mass of CCl4?
The molar mass?
Molar mass, yep.
153.
153 point what?
82.
82, thank you. And so in that case, molecules have canceled, moles of CCl4 on top and bottom, because we set it up correctly, canceled. The only unit left is grams, and that was our question. It's nice to write this at the top, because some...
What?
Say again?
0.81.
That seems to be 82 is what Ray said. And so then what would be our final answer here? Chloe, what you got, girl? Okay, well, calculators. You're going to do, I want you to plug this in your calculator correctly because I don't want you to not practice. Because, you know, practicing putting your calculator, you're saying, oh, I can totally do that. Well, you're going to make a mistake if you don't put your parentheses in. So parentheses 4.6 times 10 to the negative 25th parentheses, divided by parentheses 6.022 times 10 to the 23rd parentheses, then times 123.82. Miles or Cameron or anybody here? Robbie?
1.174982.
Okay, times.
Oh, no, that's what I got. Times 10 to the negative 40.
Negative what?
10 to the negative 46.
46.
46.
Mhm. So if you're not getting this exponent, that means that you did not put parentheses and your calculator does not know what's in the denominator. Because what happens, guys, is you put this in and it's multiplied. It's like, okay, I can multiply. And then you divide by 6.022. And then if you don't put the parentheses, your calculator thinks you're multiplying that whole thing by 10 to the 23rd. You need to keep that denominator. You need to put your parentheses. I'm just telling you now, I've seen this for 6 years where people think they know their calculator and they don't. So we get here and we have grams of CCl4. Then sig figs come involved, and what's the number of sig figs we should have? 2 sig figs, so this number here should truly be what?
1.2.
That should be 1.2 times 10 to the negative 46. Okay, let's keep rolling. Somebody at this table, EJ's group, tell me if with this question, moles to grams, is there a direct conversion or a multi-step problem here? Direct conversion, right? Again, we have molar mass. Really, this question is not about molar mass. It's about, do you know how to find the molar mass of calcium nitrate based on the distribution effect of this subscript of 2? That's really all that question's asking. Like, I know, at this point, I know you can get to molar mass, but are you doing it correctly with this formula? So then what do you do here? What do you add up for its molar mass? Calcium's mass is what? 40.08. Okay. Plus, how many nitrogens? 2. See, there's actually imaginary 1 behind that nitrogen. That 2 times 1 is 2 nitrogen, so that's 2 times nitrogen's mass of what? 14.00, right? And that's just straight from the periodic table. And then how many oxygens? 6, right? 3 times 2 is 6. So plus 6 oxygens, that's 16.00 each. Gives you what? 164. Perfect. So moles cancel with your molar conversion, and your grams are on top. You're ending with grams at the end. Your final answer, assuming that you have the correct formula, should have been 834 grams of calcium nitrate. And whenever you guys are doing these by yourself at home, say these things out loud. Say like calcium nitrate, and think about you saying 8, and think that's a polyatomic ion. Because saying things out loud means you're committing your brain to knowing that because you're verbalizing it. So your brain works in special ways. Make sure you're giving it a chance to try. All right, so then how about the next one? Do I need to do this one?
Um,
Can I do it? How many do I, so like, how many steps would this one require?
One.
One step, why?
So liters, there's a direct conversion.
There is a direct conversion between moles and liters, and that's the 22.4 liters per mole, right? And so in that one, I'll just give you guys, yes ma'am.
wait, how do you, oh, it says to liters?
The liters of that nitrogen, so that's what a single conversion. That one's 1.96 liters of nitrogen. Give me a thumbs up if you got something close to that. Those of you who got that far.
How did you,
That's the answer.
how'd you convert that though?
So I stopped showing my work at this point because I was hoping that we would have realized the single conversions were the simple ones, but I'll go ahead and set this one up. So the given here is moles of nitrogen into. The question is liters of nitrogen into. So then we just, I think Pranita just said gives a direct conversion. On the mole map, there's that final molar volume except that we haven't really actually used yet, but here we go. So you're going to start off with your 0.876 moles of nitrogen, and where do I put the liters? Top. And now liter number, what number always goes with liters? 22.4 liters of nitrogen, and that's contained within 1 mole of nitrogen. So then you'll do 0.876 times 22.4 liters, and you get, I'm sorry, 19.6. Sorry.
That's right.
My bad. I wasn't looking at my writing. 19.6 liters of nitrogen. Okay. And that was a single stepper. This one. How many steps in this one? Go. So where am I going from on my mole map?
Grams to mole.
Okay, so and this is I'm really trying to visualize this for you verbally and on a picture. We're going from our grams back to moles because that's the only connection we have, and then from moles to liters because that's the only other connection we have. And so the big question is, did you know what carbon dioxide is? CO2. We've written that about 5 times. So I'll quickly set this one up. Grams of CO2, 1 mole of CO2 on top weighs 44.01. Is that right? I just quickly calculate some of these in my head if I can get it fast enough. So your grams cancel, your moles cancel, your liters remain, and your final answer is,
Whoa.
yes ma'am.
Oh, sorry, I was still caught up on the,
Caught up on
so
me.
you're converting these to liters.
Yes. So this question says the liters. This one starts you with grams. There's not a direct conversion between the grams and liters, so you have to stop at mole first, and then we're going to go from mole to liters. And that's what this over here is: grams to moles, moles to liters. Yes.
Are you allowed to put moles over grams? Because like with yesterday you said you can only do grams per mole.
So when I ask you specifically for molar mass, its units are grams per mole. But in a conversion process, you got to do what you got to do. If you need to cancel moles, you cancel moles. If you need to cancel grams, you cancel grams. You can flip-flop that. But if I specifically say, Praneeth, what's the molar mass of lithium? And if you just say, lithium weighs 6.94 grams, I'm like, yeah, but that's not the molar mass. When I specifically ask for it, you just have to put the appropriate units. That's what I was specifying yesterday. Okay, next one. And I think this is probably the last one I do. 8 I can wait on. So hydrogen peroxide, you probably had to look up hydrogen peroxide unless you just knew it. But think about it like this. Don't you know what oxide is?
Mm-hmm.
What's oxide?
O2 negative?
O2 negative, right? So what's per mean? Plus 1 what? O2. So you actually knew that without knowing it. Okay, so hydrogen peroxide's formula, though, is H2O2. And that's because this O2 minus, O2, 2 minus, and an H1 plus get together, right? So this guy stays together. Oh my goodness. Okay, this guy stays together, you crisscross the charge over, and that's how you get H2O2. So you could do that if you needed to by yourself. But in this case, this one takes a little dissection work, right? We have got to go from hydrogen peroxide just to oxygen, which means we got to break it down. So this is the one I definitely wanted to do. Absolutely. So I know that I have to start off with 0.160 moles of H2O2. And if I want to get strictly to grams of oxygen, you're noticing I'm going to have to break this down further. And so that's where I was drawing pictures yesterday when you're looking at the atoms involved and so forth. So let me hear your thoughts on where you started here. Those of you who got started, how'd you start? grabbing?
Honestly, I think I started wrong, but I started by going to grams first.
Of the
Like the
H2O2.
yeah.
So if you got 3 grams of that, then what you would probably do next is something called percent composition. It's totally acceptable. You could totally do that, but we haven't learned that yet.
Okay.
So that is a good, there's probably 3 ways of skinning this cat, okay? But we're going to try to stick to the ones that we've learned so far. Kyle, give me something else.
I did what you did.
Okay, so we got 2 grams. Well, what if, let's just talk through some scenarios. If we went from moles to a particle, what particle would we go to for this one?
Monkeys?
Okay, we could go to molecules, and then for molecules, we could go to atoms. From using like, oh, there's 2 atoms of oxygen and 1 molecule of H2O2. But then if we get to atoms, how do I get to grams? You can go from atoms, use Avogadro's number, to moles, and then moles to grams. That's totally fine. That's the long process. There's another way I'm going to show you in a second. Yeah.
Well, on like the problems that we did yesterday, we went to molecules.
So this one, I think I'm going to start with molecules, and I'm going to show you something else in a second, because it's called an internal mole ratio. Yes, ma'am.
Why exactly can't we go directly to, why can't we go to grams first and then?
Because grams is the end of the road.
Good morning, staff. If you are administering the TSAT, you can begin that test at this time. There will be no bells, and please transition to classes following the clock on your computer.
I can't go straight to grams because once I get the grams of hydrogen peroxide, the only thing I can go from there is start to break it down into a percent. And so that percent mass we're learning tomorrow. And at the end, like, you can make a choice on what you want to do, but I'm going to try to skin this cat 2 ways for you right now. So first step first, you guys say go to molecules. So 1 mole of H2O2 going to molecules is 6.022 times 10 to the 23rd molecules of H2O2. Okay, so now we've gotten this big mole. We've gotten it down to just simply molecules. Now pick 1 molecule out of the air. You have H2O2 in your hand, right? H2O2. I have 1 H2O2. 1 what of H2O2? 1 molecule. I picked 1 out of the air. Let's just say I have 1 in my hand. So if I have 1 molecule of H2O2, and I looked at it really closely, how many atoms of oxygen would be in it? 2. You can see that from the subscript. You can also draw it out. Do what you got to do. There are 2 atoms of oxygen within that H2O2 molecule. You with me so far? Okay. And this is where Kyle's like, you got to go back to moles. Well, let's kind of see where we can simplify at the end, but let's go back to moles now. Because atoms right now, I'm stuck at the end. I can't, there's no conversion between atoms and grams, as you can see here. Or particles and grams, there's no direct conversion. So that's why we do have to go back right now. Give myself some space. We do have to go back. And what would you put on the bottom? Because so far moles have canceled, molecules of H2O2 have canceled, we have atoms.
Just go back.
That dude's number, okay, 6.022 times 10 to the 23rd, atoms of oxygen in what? Well, we are totally done with hydrogen peroxide. Don't even touch anymore. We are done with that baby. So atoms of oxygen, there are that many atoms of oxygen in 1 whole mole. That's the relationship between Avogadro's number and moles. And now, if you had to go to mass of oxygen, could you? Yeah, I'm in moles of oxygen. I can go anywhere from moles. I am in moles, and that's the desired unit for now. But now we need to get to grams. So what would I now put? 1 mole of oxygen contains 16.00 grams of oxygen. That's from your periodic table. Guys, that is a perfect way to skin this cat. We've gotten 5 steps up here. It took a little while, but we got it. So we could just go ahead and say, oh, where's my paper at? That final answer should be 15 or 5.12 of oxygen. Absolutely check. And I'm going to show you where we see. Say again? I'm going to show you another way. You tell me if you did that right, okay? Because what you're noticing here is what could you simplify before putting in your calculator? Look at our math.
You can simplify Avogadro's number. It's on the bottom at 1 point.
Yes. So it's on the top here, 6.022 times 10 to the 23rd, and it's on the bottom here. So I'm not going to waste my time and put it in there twice. Because obviously you can see they cancel each other out, right? So we can see they cancel each other out. So what do you really just put in your calculator? 0.16 times 2 times 16. All right, so that in your calculator would be 15.12. So what we really did should be 5.12. Is that right? Okay. I hope so. My calculator fingers are sometimes better fingers. So as we see here, we can see the simplification process occurs. That's probably because there's something simpler we could have done to begin with. And this is called an internal mole ratio. And so I'm going to write this below this question. And I'm going to start off exactly what we did here, 0.160 moles of H2O2. And we're going to do something called internal mole ratio, which means you look at the subscripts and you decide on a ratio that they exist in. Well, here's what we did earlier, right? If I have one H2O2, how many oxygens are in an H2O2? 2. So that ratio is a 2-to-1 ratio, right? Well, I didn't say anything in particular. I didn't say molecules or atoms. I just said a thing of H2O2. So that single one of these guys, I'm going to call a mole of H2O2. So 1 mole of H2O2 contains twice as many oxygens in it. That's truly twice as many moles of oxygen within the substance. It's called an internal mole ratio. And all I'm doing is looking at this 2. This 2 here is that internal mole ratio. So truly that means I have 2 moles. Oops. I have double the oxygens within a single compound, within a single molecule of H2O2. So, and if you like this and you know how to use it, then feel free to use it. But really, it's just a simplification of that first process. So if you're happy with that and you understand that, stick with this for now. But this gets me to moles of oxygen, right? Totally surpassed Avogadro's number. Now, if I had to get to grams, what would I do?
You just put the 16.00 on top, and then 1 mole on the bottom.
There you go, and you're there. Okay, so that's a 2-step process versus a 5-step process, but the 5-step process makes a lot of sense because you literally just learned this yesterday. You just learned these connections yesterday. So if you're happy with the 5-step process, do it for now. We'll get to the point where we're happy with this. We got a lot more stoichiometry to get behind our belt before we can really get there. Okay, so I'm going to pause for now. Does that clarify some of your questions? Specifically 7, because I'm sure that was the hardest one. Here's what I want to do now. We're going to go outside, and we're going to do a moles of chalk activity. I have to tell you what chalk is made of. We're going to draw our names, I love chemistry, write chemical formulas, draw chemistry pictures, keep it PG-13, and we're going to then figure out the moles of chalk that we utilized. So keep it PG-13 is what I mean. So this is what you're doing. Okay, you have to get a piece of chalk. You have to mass your chalk first. Okay, you have to mass it because once you start drawing and you come back and you mass it, you got to know the mass difference. You got to know how much chalk you used. And after that, we're going to take the mass of chalk we used and we're going to be just converting it just a little bit further to make sure we know what the heck we're talking about now. Okay? So, let's get a piece of chalk. You do need a piece of paper to write down your chalk mass. You can do it partners, you can do it individually. I don't care. You did it with I'll do that. That's actually really smart. Nice shortcut. I'll admit, nice shortcut. I'm like, whoa, no way.
It's your sample house. And then we're going to craft that movie.
Yay! I like to make a mess. Always. Like always. Okay. Come on, Chloe. Come on. Oh.
you gotta get your mouse first, that's all you need, the initial mouse.